Germany today. Wind, biogas, and solar energy provide nearly a quarter of total electricity needs. Germany, 40 years later. Renewables deliver 100% of the country's needed electric power. Traffic runs for the most part on electricity. Solar power systems line major traffic arteries, and the sound of an intersection is not what it used to be. There can even be idyllic conditions right next door. As a rule, buildings in cities are powered by solar energy units that have long ago become a part of the facades. Many buildings store excess solar power in a battery located in the cellar. That way, the sun's energy is even used at night. In some residential areas, there are special batteries for several homes. When the wind, biogas, and solar power plants produce more green electricity than needed, electrolysis plants store the surplus renewable energy. In these plants, water is turned into energy-rich hydrogen gas. In a neighboring plant, the hydrogen bonds with carbon dioxide to form methane gas. The methane flows into Germany's national gas grid, replacing more and more natural gas. Part of the biogas also flows into the grid. Along with underground gas caverns, the grid itself is also a gigantic long-term storage facility for renewable energy. If the wind doesn't blow or the sun doesn't shine, the gas flows into large and smaller gas power plants that produce electricity. There are many ways to store biogas, solar, and wind power. These sources will provide 100% of Germany's electricity needs by the middle of this century. Around the clock, no matter what the weather. This vision provides the guiding concept for scientists at the Fraunhofer Institute's Wind Energy and Energy System Technology, or EVES, in Kassel. They're researching Germany's transition to renewables in a special data processing center where they simulate thousands of small and large-scale biogas, solar, and wind power plants as well as power grids. They mathematically model this digital energy landscape down to the last detail. For example, one mouse click tells the researchers what the output of wind power plants in the Cuxhaven region will be in the year 2047. Along with plant simulations, historical weather data is also collected, allowing scientists to estimate how many kilowatt hours will flow through a substation and into the grid on a windy spring day in the middle of the century. That way, scientists not only learn where renewable energy can best be added to the existing power grid, they also learn where the grid could be expanded and how it should work in the future.
Renewables have to provide enough energy and electricity, as well as power ancillary services, above all maintaining frequency and voltage stability.
Along with simulating the digital energy landscape in the data processing center, researchers also carry out concrete tests outside in the real world. They want to find out if renewable energy alone can produce the desired frequency and nearly constant voltage needed in high-voltage power lines. The problem is, conventional power plants have always provided the exact amount of electricity needed by consumers at a given moment. When supply and demand are in balance, alternating current has a frequency of 50 Hz. That means the electrons in the power lines oscillate back and forth 50 times a second. If the power plants feed too much electricity into the grid, the frequency increases. If they feed too little, the frequency falls. But all the electronic devices used by consumers are designed for a 50 Hz AC connection. Strong deviations can lead to severe disturbances in factories and in private households. That means equilibrium between the supply and demand of electric energy must be maintained at all times. And in the future, this job will have to be done above all by renewable energy. The problem is, no one can influence the sun. And that's true at this large-scale solar power plant near Kassel as well. The Fraunhofer Institute's EVES has a special testing center at the north end of the plant. Here, scientists are preparing an experiment. Their goal is to maintain the balance between the supply and demand of electric energy with the help of renewable energy alone. To that end, the scientists connect several biogas, solar, and wind power plants together, forming a combined power plant. Ultimately, they're aiming to maintain a stable frequency in the power grid.
Plant running at 400 kW.
Please provide 50 kW of control reserve.
The Willingshausen biogas plant in Hesse provides what's known as control reserve. That means the plant, along with the solar power plant also used for testing, releases only a controlled amount of its output onto the grid. If more electricity is needed in the grid, the plant's output is increased. If less is needed, the output is decreased. Teams on location are preparing the plants for the experiment.
Everything okay?
Looks good.
Is the wind farm ready?
The wind farm is ready.
A wind farm in Brandenburg is also taking part in the test. Here, 32 wind turbines can provide more than 50 megawatts of power. In preparation for the test, technicians decrease the power output by adjusting the angle of the rotor blades. The rotation speed and power production decrease immediately.
It's not only a matter of keeping the frequency stable in the grid, it's also about keeping the voltage stable.
An overhead power line operates at several thousand volts, and the voltage must remain nearly constant along its entire length. AC current flowing through a high-voltage power line creates a coupled electric and magnetic field. In our grid, these fields oscillate just like electricity at 50 Hz. If they both rise and fall at the same time, power can flow almost without interruptions. The problem is, power lines are several hundred kilometers long, and over long distances they delay electric and magnetic fields by different amounts. As a result, the electric and magnetic fields no longer oscillate in sync, and the voltage is also reduced because of this increased resistance. Until now, it was mostly conventional power plants that balanced out these forces. That's why, in addition to the frequency experiment, the scientists are carrying out a second experiment with voltage control.
How's the voltage?
It's fine.
Using special simulators, they produce electromagnetic fields. These simulators are meant to counteract the voltage reduction. Located in the testing center, They create the same electromagnetic fields provided by biogas, solar, and wind power plants outside in the real world.
To all plants, the experiment is starting.
During the experiment, a computer simulates quickly changing power consumption. And it's precisely these fluctuations that have to be balanced in the plant. The frequency rises, too much power in the grid. The biogas plant now has to reduce its output immediately. And the solar plant has to reduce its power output as well. The frequency falls to the desired 50 Hertz. At the same time, the voltage experiment is also running. The computer simulates a several 100-volt drop in the tension of an overhead power line. The plant that simulates the electromagnetic fields of a wind power plant immediately feeds electricity into the grid. Once again, the voltage starts to rise. At the same time, the frequency drops in the other experiment. That means more power is demanded than supplied to the grid. The wind farm in Brandenburg still has 4 megawatts of positive control reserve on hand. That means some plants are not running at full capacity. The blade angle is altered. The turbines rotate faster. And the frequency rises. In the simulated grid as well, the electric and magnetic fields are oscillating in sync again. The voltage has reached its previous level.
And we're back to 20 kV.
And finally, voltage and frequency are constant.
Our experiment showed that renewables provide an adequate supply of constant energy and ensure a stable voltage frequency.
What the workers in this combined power plant experiment demonstrated on location will happen in the future automatically with the help of digital data transfer. The theoretical and practical experiments also showed where and how much green electricity will have to be fed into the grid in the future, and what need there is for new power lines. If engineers modify the grid to meet the new challenges, frequency and voltage will remain stable, and Germany's energy transition will succeed. The vision of 100% renewable energy can become a reality. Solar, biogas, and wind power plants complement each other. By the middle of this century, they will form the supporting pillars of climate-neutral and secure power production. And even after dark and with little wind, the lights will stay on in Germany.